Hi, once again, this is Professor Elliott, and in this short presentation, we will be discussing Ohm's law. Ohm's law is a fundamental relationship between the three quantities of voltage, current, and resistance, and all electrical or electronic circuits obey Ohm's law, so it's very critically, super, ultra, definitely important for you to master this as soon as possible. Okay, voltage, which we've already defined earlier as electrical pressure, is the product of current times resistance. And if we're working in the base unit of volts, if we multiply base unit of current at amperes times ohms, we get volts. We could also say that voltage is equal to milliamperes, which is 10 to the minus 3, times k ohms, 10 to the plus 3, the minus 3 and the 10 to the 3 cancel, and you're left with volts. Likewise, we can say that microamps, 10 to the minus 6, times mega ohms, 10 to the plus 6. Again, they'll cancel out and give us the base unit of volts. Okay? So summary, V, voltage V equals current I. We usually use I for current. We just do. Times R for resistance. Current is voltage divided by resistance, and the base unit of current is amps divided by volts, and ohms gives you amps. We could also say that volts divided by k ohms gives us current in milliamps, or voltage divided by mega ohms gives us current in microamps. So current I is equal to voltage divided by resistance. Okay, finally resistance is voltage divided by current. So volts divided by amps gives us ohms. Volts divided by milliamps gives us k ohms, and volts divided by microamps gives us mega ohms. Formula R equals V divided by current I. Okay, some of the relationships, voltage versus current, we'll be exploring these in the lab. And so here we're going to have a little circuit here, battery. Okay, this line through the battery simply means it's a variable or adjustable voltage. Let's use a resistor. Resistor is a device which opposes current. We'll be learning all about those. Okay, and let's say we start the volts at 0, okay, and we raise it from 0 to 12 volts, let's say in 1 volt steps, and the resistance is fixed. Let's just say it's 10 ohms. Then have a linear line that as we increase the voltage, we get a corresponding linear proportional increase in the current. Remember, the current is voltage divided by R. So for homework, I want you to scale, to take a sheet of graph paper, plot this out, right? Let's say in 12 steps. So obviously 0 volts, the current here is going to be 0, okay? And I want you to increase the voltage, the battery, 1 volt at a time, and calculate the current based on the fixed 10 ohm resistor and plot it for each of the steps. And I want you to prove to yourself that this is a linear relationship. Okay? Don't just take my word for it. Go do the homework, and you'd be better off for doing it. Okay? All right, next. Okay, current versus resistance. Okay, so in this case, if we increase the current, the resistance, and monitor the current. The current's going to decay down like that. So that means that theoretically, if the resistance is infinity, which is an open circuit, that means then that the current will be 0. Alright, so this is, we have this circuit, we have a battery. Okay, we use the same, this time it's going to be fixed at 12 volts. Okay, so we're going to have a variable resistor R, and let's say this is 20 ohms. Okay, so if we start that off at well, if we start at 0 ohms, the current would be infinity, which is what we're showing here. But let's say, what's the next? Oops, I need another slide here. Okay, so let's say that we're going to leave the voltage constant at 12 volts, and we're going to let, what's that, 20 ohms? We're going to let R range from, let's say, 2 ohms to 20 ohms in, I don't know. Let's go 2 ohm steps. All right. Okay, so your first calculation, you're going to do this for homework and work it out and graph it out. Okay, so we're going to calculate the current. So we're going to let R equal 2 ohms. So therefore the current equals 12 volts divided by 2 ohms equals, that'd be 6 amps, right? And then we're going to take R, we're going to increase it to 4 ohms, and then current I will be 12 volts divided by 4 ohms. Okay, 3 amps. Okay, and then R equals 6 ohms, and then I would be 12 divided by 6 equals 2 amps. Okay, then you come back to the graph, and you're going to plot all those points along the graph, right? And then draw a smooth line, and just prove to yourself that this is actually the relationship. Okay, and so once again, back on here, if the resistance was 0, which would be a short circuit, which we're not going to do, the current would theoretically be infinity. If R here was infinite, then the current would be 0. But anyway, plot the curve out and see what you get. It's really important that you, in the beginning, that you get real comfortable with these quantities and relationships, so they're not just mathematical formulas. Okay, it's not a good idea to just go by the formulas alone. And once you have a good understanding and feel for what you're dealing with, it'll just make your life so much easier. Okay, so all right. So in summary, voltage is the product of current times resistance. Resistance is volts divided by current, and the current is the volts divided by the resistance. And this might be a memory aid that's useful to you, at least in the beginning. Shouldn't really use it, but in the beginning anyway. And I hope you enjoyed the lesson and get to know Ohm's law. It's not going anywhere, and you won't get very far without it. Okay, thanks, take care, cheers, bye.